Okay, folks, moving into this next topic, we are going to discuss polyprotic acids. Okay, and by polyprotic, we mean contains many protons. So, as an example here, we have carbonic acid, H2CO3. Okay, and carbonic acid is a polyprotic acid as well as a weak acid. So you can see right here, it goes under its first proton dissociation to make H plus and then HCO3 minus, which recall that's bicarbonate. And you can see Ka, which we call Ka1 for the first proton, is pretty small at 4.3 times 10 minus 7. However, now notice what happens here. The bicarbonate, because it has a proton on it still, can also dissociate to release another proton, and then just regular old carbonate. Okay. And you can see the second Ka is much smaller. And this is very typical that for a typical weak polyprotic acid, the first Ka is always greater than the second Ka, which is always greater than perhaps a third Ka, for example. Okay, so other examples of polyprotic acids, so sulfuric acid, H2SO4, right? Let's see, phosphoric acid, H3PO4, so that will undergo 3 dissociations. Okay, and so here I've got this nice example on carbonic acid in the environment, as it's actually related to ocean acidification via climate change. So ocean acidification. Okay. So the way that this works, all right, we have CO2 in the gas phase in the atmosphere, and it can get taken up quite readily into natural waters, oceans, rivers, lakes, streams. CO2 is very soluble in water. And when that CO2 gets taken up into water, it will react to form our carbonic acid. And notice that that is also an equilibrium reaction, just making the carbonic acid in the first place. Okay. And then now this carbonic acid will go on to make H plus and bicarbonate. Okay. And that H plus can actually dissolve calcium carbonate. So as one detrimental effect, that can really affect coral. Okay. But also there's a nice Le Chatelier's principle going on here, right? As we increase more and more CO2 into the atmosphere, it's going to just push this equilibrium all the way to the right, generating more and more H plus. So unfortunately, the more CO2 we create via combusting fossil fuels, the more we acidify the ocean. And that is proving to have some pretty detrimental effects on sea life, unfortunately.